Good day, everyone. Welcome to the Spark News. We're bringing you the latest news updates from around the country, covering events that matter most to you. Stay with us as we dive into stories that impact our community, our economy, and our everyday lives.
Professor Chris Hewitt will now walk us through the specific findings that demand our attention. Chris, over to you.
Thank you very much, Co. Several spoilers there. I will indeed go into the details now. And we have some slides to illustrate the results. So if it's possible to get those up on the screen, please. Thank you. So this update combines consolidated data from 2024 and preliminary 2025 data when it's available, giving a near real-time view of global climate trends. The findings are mostly not positive, as Co has just said, record greenhouse gas levels, warming, melting. But we do also report some positive progress as well, such as science-informed NDCs, nationally determined contributions, and early warning systems. And as Co mentioned, so we can see on the slide here, we do also provide context for IPCC. I won't go into the details, so that's in the IPCC's report, so their most recent assessment report from 2021, but it serves as background information for context if you're interested. So let's go straight in. This slide here showing atmosphere, so I'm going to show several essential climate variables, and this one is greenhouse gas concentrations. So 2024 is the most recent year for which we have global consolidated figures for greenhouse gases. So that's what we're showing here, but also to note that we do have some figures for 2025. So 2024, the key message here, the greenhouse gas concentrations reach record observed levels. And so the figure on the right, you can see atmospheric carbon dioxide concentrations, for example, going back to 1984. So these are annual averages, and you can see the long-term increase, the trend in atmospheric CO2. And real-time data for 2025 from a few stations shows that these trends are continuing into 2025. The figure at the bottom right shows the growth rate, so this shows the change from year to year, and the key point here is that the increase in concentration for CO2 between 2023 and 2024 was a record increase in the recent observational history. So we're continuing to see greenhouse gas emissions rising. I said I wouldn't go into the context, but I think this one particular one from IPCC is very useful. So the observed increases in well-mixed greenhouse gases, gas concentrations are unequivocally caused by human activities, and continued greenhouse gas emissions will lead to increasing global warming. And so that's a message that we'll see on following slides. Next slide, please. Now on to temperature. So we use 6 global data sets to monitor and assess global mean temperature, and they're shown on the figure on the right there. 3 of them go all the way back to 1850, and then we have more data sets come online. So by 1940 we have the 6 data sets, and these are showing annual average global mean near surface air temperature going back to 1850. So for temperature, we have data from January to August from all 6 data sets, and we don't have data from all of the data sets from September and October yet. So these results, these provisional results in time for COP, are for January to August, and the average for those 8 months was 1.42 plus or minus 0.12, so we do have some error bars around this. Degrees C above the pre-industrial average, so an 1850 to 1900 average. So what that means is that 2025, this year, is on track to be among the 3 warmest years on record, so the 2nd or 3rd warmest year on record. Clearly we have several more months to go before the year is finished, but it's on track to be among the 3 warmest years on record, and all 3 of the warmest years on record are the most recent 3 years. In fact, the past 11 years, if we look back, you can see a lot of variability from year to year, but the past 11 years have each been in the warmest 11 years on record, which is actually unprecedented, apart from, of course, the first 11 years, which obviously were the warmest at that time. But since then, so we haven't seen such an extended period where we have such a pronounced warming, and you can see it quite clearly on that graphic. Next slide, please. Moving now to the cryosphere. So this is a figure for glaciers. So we've been monitoring glaciers all around the world, and this graph on the right goes back to 1975, showing glacier mass change, so the balance of masses of glaciers. So in 2023-2024, this is the hydrological year we used to observe glaciers. Glaciers lost a record 1.3 metre water equivalent of ice. We've tried to express that in different units. So that's equivalent to 450 gigatons, or in terms of sea level rise, that would equate to 1.2 millimetres of sea level rise. Maybe one more statistic if it helps. We've estimated that would equate to about 180 million Olympic-sized swimming pools if we were to put that water into Olympic swimming pools. These are difficult numbers to get your head around. So a large decrease. 2024, last year, was the third consecutive year that all of the 19 glaciated regions that we monitor recorded a net mass loss. So all of the regions are recording a net mass loss. And Venezuela lost its final glacier, which joined Slovenia. So these are the first two countries to lose all of their glaciers in modern times. Next slide, please. Going down now into the oceans, so there's two figures here relating to the oceans. So the figure on the left, ocean heat content. So over 90% of the excess heat trapped by greenhouse gases in the atmosphere goes into the ocean. So the heat from the atmosphere is driving the warming in the ocean. So the graphic here shows the changes back to 1960 from 3 different data sets, and again you can see a clear long-term trend, so increasing ocean heat content, and this is from the surface down to 2,000 metres. And the ocean heat content for 2024 was the highest on record in that time series, and preliminary data for this year show that we are continuing to see those increases in ocean heat content. Ocean warming is irreversible on long timescales, centennial and longer. It can drive marine heat waves, loss of sea ice, sea level rise, degrades marine ecosystems, and can intensify tropical and subtropical storms as well. So this is an important metric to monitor. The figure on the right is sea level. So this is global mean sea level going back to 1993 based on satellite measurements. And again, you can see a clear long-term increase there over that time period. Quite a lot of variability. However, the long-term rate, so if we look at the first decade compared to the most recent decade, the long-term rate of global sea level rise has doubled from 2.1 millimetres per year at the beginning to 4.1 millimetres per year in the final decade. And preliminary data for 2025, you can see on the right-hand side of that figure, there's a slight temporary dip compared to 2024, which needs more investigation, and it's likely due to natural variability. So we saw a similar event back in 2011, if you look, and that was related to large changes in inland water storage. So this is an active area to be studied throughout the rest of the year. Next slide, please. Jumping back to the cryosphere, but building on the ocean results there, so now looking at sea ice. So the figure at the top right is the daily Arctic sea ice extent. So this looks through the year now, and at the bottom is the same for Antarctic, so daily Antarctic sea ice extent. So if we look at the top first, you can see all the different years going back to 1978. They're all plotted on here, and then the 30-year average is the solid black line. And then the blue line shows the picture for 2025 to date. And unfortunately, the 2025 maximum Arctic sea ice extent, so the winter sea ice extent, was the lowest in this satellite record. So that's the lowest maximum sea ice extent in the record. And the whole year, as you can see so far, is below a long-term average. For Antarctica, again, the long-term average, you can see the whole year is below average. It's not record minimum, but it's third record minimum and maximum sea ice extent for Antarctica. So sea ice is below average. Next slide, please. We also document extreme events around the world, and so in the actual report there's more details. So it's in the report, you see there's lots of details here, so we've just picked out the key words here. So there's been a diverse range of extreme weather and climate related events so far in 2025, including heat waves, wildfires, droughts, floods and storms. And these are having major humanitarian and economic impacts, damaging crops, displacing populations, deepening poverty, loss of lives. And the extremes have continued beyond this first half of the year, so Hurricane Melissa would be a recent example in our memory, a clear example of how the year's severe weather is still unfolding. And I see now there's a typhoon, a very destructive typhoon in Southeast Asia at the moment. Next slide, please. I think this is my final slide. So that was all bad news, as Co did warn us. But it's not all bad news, so there are some positive signs as well. So on the left here, National Meteorological and Hydrological Services, these are WMO's members, they're playing a growing role in implementing science-based climate action all around the world, providing climate services and early warnings, such as heat health alerts, agricultural forecasts. And so the graphic on the left shows the reported contributions to nationally determined contributions. So this is where countries are noting the role of climate services and early warnings where they're mentioned in NDCs. And so, for example, the most recent NDCs, more than 70% of those are now referencing climate services or early warning systems. So this is good progress. On the right, early warning systems are, of course, absolutely essential to deal with these extreme events, which were on the previous slide as examples. And so it's very pleasing to see that the number of countries that are reporting multi-hazard early warning systems has doubled. So since 2015, there were 56 countries reporting multi-hazard early warning system in their country, and now we're up to 119. However, 119 means that 40% of countries are still lacking such systems. On the plus side, progress is strongest in least developed countries and small island developing states. And at WMO, we're very much supporting them through improving observations and access to WMO's integrated processing and prediction system to help provide forecasts and warnings. But continued investment is needed in data sharing, forecasting and local preparedness so that we can reach universal coverage by 2027, as called for by the UN Secretary General in the Early Warnings for All. So